Thank you, Paul. As Paul had mentioned, I'm Alan Jarvis, a lift consultant with TÜV Süd Dunbar Boreman. I'd like to thank you all for joining me today. I'll get started. Obviously, I'd like to begin, if we may, basically with a sort of brief introduction into the history of firefighting lifts. Basically to set out why we have them, what happens if they fail, and how to make sure they don't. Tall buildings have been around with us for millennia. I think everyone will recognise some of these iconic buildings. Great Pyramids of Giza, the Colosseum of Rome, and there's also buildings here that date back to the 1500s in Yemen, which were roughly 8 stories high, approximately 29 metres in height. In the 19th century, the high-rise building boom, I suppose, gave rise to quite a number of revolutions. One of those was obviously tall buildings, and going back as far as 1856, right through to, as I say, the 2000s, you can see the dramatic rise in height of buildings. With tall buildings, also came the invention of the modern lift, or elevator, as it's sometimes called. That in turn meant that when we had tall buildings, we also had tall building fires. And I suppose for anyone that's as old as me that can remember the movie The Towering Inferno, it's I suppose that at that time was fiction, but these things are very clear now that it's no longer fiction and very real in everyone's minds. So I suppose, what's all this got to do with lifts? What we'd like to focus on here is, of course, firefighters' lifts. Firefighters' lifts are required when you have buildings of particular heights. Certainly within the UK, regulations differ across the globe, but certainly within the United Kingdom, where we have buildings that have an uppermost story above 18 metres, then the building's regulation require a firefighting shaft and a firefighting lift. Additionally, when you have deep basements where it's difficult again to get to lower levels, then firefighting shafts and lifts are also introduced. So firefighting lifts essentially for buildings 18 metres tall. So what is that in practice? I suppose it's typically a building that has about 6 stories above ground floor, given roughly a sort of 3-metre height rise. So size matters. I mean, we go back here and we see it 2020, we're looking at 18 metres, and 2021 now. Those buildings were smaller than the building there that you can see in 1856, which was actually the Howard building in America, where the first commercial lift was installed by Otis at that time. So today we require firefighting lifts in buildings lower than that building. And there's a very good reason for that. So I suppose, why does size matter? I suppose principally because most ladders are constructed on fire appliances to reach 18 metres. I believe there's a couple or a small number of ladders that can go above that height, but in general, most ladders only reach 18 metres. So what are the other options? I suppose, well, principally it's either, use the elevator to get to those heights if the appliance can't reach it itself. There's 2 clear benefits that we see with firefighters' lifts. One, early evacuation. Now, in principle, firefighters' lifts and evacuation is a managed process. It's not that everyone just evacuates from the building via the lift. It needs to be a managed process. But certainly for disabled users or people with mobility difficulties, that lift can be the difference between, saving their life if they are trapped within a building at a high level. Additionally, it also allows and enables rapid deployment of firefighters. Without these lifts, then firefighters have no alternative but to use staircases within buildings. At Grenfell, you can see I suppose the outcome of firefighters having to use the stairs. The fatigue involved is phenomenal. So lifts can really improve the mobility of firefighters and to enable rapid deployment. So going back to Grenfell, I suppose you know this sort of image here that we've got on the right hand side seeks to illustrate how rapidly the fire spread. At 1:30 a.m. you can see that basically on the upper left of the building there, the fire started at a lower level, but in the upper left you can see that the fire has spread quite rapidly at that stage. Within 2 hours, the whole building is almost consumed by fire. So that 2 hour period is critical for evacuation and rapid deployment in a building. So I think it's clear that the early evacuation and rapid deployment is certainly essential. So what happens, I suppose, when firefighters' lifts and firefighting equipment fails within a building? Again, going back to Grenfell, what went wrong here? Well, I think most people now are aware of the fact that a fridge had failed. In addition to that, the cladding failed, which increased or promoted the spread of the fire within the building. In addition to that, the lifts failed. When the firefighters arrived at the building, they were unable to get control of the lifts because a switch had failed, and that was the fire control or fireman switches within that particular building that had failed in that situation. You can see on this image, which is from the Grenfell inquiry, that the firefighter at the right hand side is trying to operate the switch. The switch didn't operate, which meant that he was unable to take control of the lift. So he can now be seen pressing the button for the lift to try and get control of the lift at this time. While this is happening, there's obviously people in the lifts because the lifts continue to operate. They're not under managed control by the firefighters or anyone that could have been involved in managing the evacuation. So the lifts continue to operate as normal within the building. In this particular building, that obviously meant there was people on the 23rd floor and stories below this, which were trying to escape from the building, and firefighters trying to get access to those floors from the bottom or the entry level. You can see on this typical residential layout plan here that the stairs were straight across from the lift, so that was the only alternative route of escape. So in this instance, early evacuation and rapid deployment failed. What I'd like to do now is to look at what we can do to make sure that lifts don't fail. And I suppose it all comes down to reliability. There's a number of features that firefighting lifts have that improves their reliability. They have backup power supplies. That means that in the event that the primary supply to that lift is damaged by fire or fails, that a secondary power supply is provided to enable the lift to continue to operate in the event of a fire. Those secondary supplies are often run within fire protected areas to increase the level of safety. Firefighters' lifts have water protection also. It's quite clear that when we've got lifts that operate during firefighting operations, that they can become damaged by water. So there's arrangements within the standards for those lifts that ensure that you can provide ramps to prevent water entering the lift shaft or drainage gullies to allow the water to drain away. In addition, they have protection within the shaft of equipment within the sort of immediate vicinity of the door tracks to prevent water damaging the electrical equipment. It's also protected against water. They have heat-resistant protection on doors and other equipment within the lifts. Those doors are tested under lab conditions to meet stringent requirements to demonstrate their fire resistance and their ability to withstand fire. You can see on the right-hand side there, a timer running there. So most doors that would typically be provided would have a 2-hour fire rating. That typically exceeds the rating for other fire doors within buildings. They have communication devices that serve to allow the firefighters to communicate with other firefighters inside the lift car and also with the lift machine room in the event that they need to arrange to move that lift or release someone that might be trapped. They also have special controls that allow firefighters to control when the doors open when they take the lift to a floor, and also to prevent the doors closing automatically when they have the lift. Clearly at Grenfell, none of those features were available for firefighters, which meant, as I say, the doors would just operate as normal. Finally, they have escape and rescue routes, such as trap doors, facilities like ladders, which permit the ability of people trapped inside the lift to escape. This is intended for firefighters, and additionally, if anyone's trapped within the lift, it would allow their rescue from outside the lift. So I'd like to touch again on the sort of causes of failures. Typically, we've spoke about things like damage to cables and power supplies and water damage, etc., heat damage. There's also misuse. So lifts can fail as a consequence of misuse, such as active vandalism, people that may overload or jam objects within the door tracks, preventing the lift operating as normally. Our focus principally here is on maintenance. It was quite clear that at Grenfell that the switches were not connected and hadn't been tested. So again, there's lots of different things that can feature here that could cause a problem when lifts need to be provided in an emergency, such as wiring faults, buttons not working properly, and problems with communication, or again, no arrangements for the owners to test the lift. So there's lots of different areas there which could affect the reliability of lifts, and not all of those are under the control, if you like, of the lift contractor. Some of them are the responsibility of the owners. To recap, I suppose principally we can do things about power failures. Firefighting lifts have these facilities already built into them. Again, similarly with water damage and resistance against fire. Misuse is something that we really can't control. We can do all we can to mitigate against those things, such as CCTV, etc. But poor maintenance is something we certainly can do something about. I'm sure you'd all agree. What does world-class fire safety look like? Well, the Burj Khalifa, if anyone's been fortunate enough to take a ride in those lifts, that building towers 828 metres. The stairways are within reinforced concrete cores to our fire-resistant construction. Has the fastest elevators in the world, 10 metres per second, approximately 22 miles per hour. And again, those lifts are situated within a fire-resistant concrete core. And the building has 38 smoke and fire resistant evacuation lifts, which is pretty phenomenal. But I suppose a building of that height requires those types of features. In addition to that, it has a world-class maintenance system and maintenance arrangement in place for the safety of those lifts, and has routine inspection and testing. So I think, again, just to summarise, this is not rocket science here. What we're talking about in terms of routine maintenance is to check fire switches. There's guidance documents already in place, such as British Standard EN 8172 and BS 9999. Those documents provide clearly documented recommendations and guidelines for routine testing. And the sort of list that I've provided here is a sort of summary from those documents, which demonstrates that there's clearly arrangements that should be in place to make sure that those lifts that we depend on in the event of a fire are there and are available when we need them. So to summarise, maintenance matters. It's clear that firefighting lifts are certainly critical to allow evacuation and rapid deployment within tall buildings, and failure can cost lives. So good maintenance is essential, and hopefully today we can have a brief maybe Q&A session here about this, where we can hopefully talk about some of these points further. I'd like to pass you back to Paul Mist now for any Q&A. Thanks, Paul.
Thank you, Alan. Let's move through some of the questions we've received. Do you need firefighting lifts in all buildings above 18 metres?
So it's a very good question, actually. Thanks for the question. I suppose the short answer is we would have these in new buildings because new buildings need to meet new regulations. There's many existing buildings already around there. Again, many of these tall buildings, certainly within the UK and elsewhere in the world, they were constructed around the sort of 1960s and 70s, when the sort of firefighting codes and standards that we have now just weren't around. So there's lots of tall buildings that still are there that don't have firefighting lifts. They may have lifts of one form or another that may be different standards at that time, but firefighting lifts would be provided in new buildings to meet new building regulations.
I have another question from one of our attendees here. Whose responsibility is it to ensure that firefighting lifts are regularly inspected and checked?
So again, a very good question. I suppose I see this as a joint responsibility. Firstly, it's the responsibility of the duty holder or the owner of that building, or the person that they might appoint as an agent to make sure that they've got maintenance arrangements in place. So those maintenance arrangements would have to make sure that lift equipment is properly maintained, and if you've got firefighting lifts, then you'd need to have the proper arrangements in place. Additionally, if you have a contract with a lift maintenance provider, then the maintenance provider should be able to provide you with advice on what regular inspection procedures should feature as part of that maintenance arrangement. So I suppose it's a joint responsibility, one firstly of the owner, and if they appoint a maintenance contractor or supplier to provide the service, then they in turn have to make sure they provide the right and relevant level of maintenance for the equipment.
Okay, thank you, Alan. Got another one through the Q&A. Do all fire lifts have the features you describe?
I sort of touched on this, I suppose, earlier in the first question. No, they don't have all those features. Fire lifts, again, and that term, it can be confusing. There's been many different, I suppose, names and definitions given to lifts that can be used, shall we say, of the fire and rescue services. Around the 60s and 70s, they were often referred to as fireman's lifts. That term simply meant that they had a switch that would allow the fire and rescue service personnel to take control of the lift in the event of a fire. It didn't really do much more than that. As standards progressed, new features were introduced. Again, things like fire-resistant doors, hatches, etc., until we come up to modern standards. So, in short, I suppose what I would say is they don't all have the features that I've described here within this presentation, as in backup power supplies. But what's important, and this is becoming more and more relevant, is that it's important to establish what features your lift does have, and to make sure that the fire and rescue service are aware of those features. If they need to use that lift in the event of emergency, then obviously if it doesn't have all of the protective or control measures and special features that I've described, it's important that they understand the risks that they would be presented with if they have to use it in the event of a fire. So I would certainly recommend that anyone that's responsible for lifts undertakes a risk assessment to establish what features the lift does have, and consults with a local fire service.
Perfect, thank you. Another question that's come through is, can an existing lift be converted to a firefighting lift?
So again, short answer, not necessarily. It would depend on certain features within the building. I'd mentioned earlier on that things like drainage, ramping, etc. It may be that the lifts that you have in your building are standard passenger lifts, and you don't have all of those features. It may certainly be possible to ramp and introduce those features. Again, there's some guidance within British standards. 8899 is one example that provides a means by which you can establish whether or not you have to introduce, if you like, additional features or make alterations to your building to accommodate fully compliant firefighting lifts to current standards. In short, it may be possible, but not necessarily always possible.
Thank you. Another question I have is, would a lift installed in the last 3 months have all the features, ramps, drains, hatch in the lift car, etc.?
So if a lift was installed in the last 3 months, I'm assuming that this refers to a firefighting lift, as it would have to be provided and supplied. So again, not clear from the question whether this is a firefighting lift, but if it's a standard passenger lift, then it won't have those features. If the building was required to have a firefighting lift, then it certainly should have all of those features. You don't necessarily need to have drainage if you've got ramps and entrances, or pumps, etc. The standards have sort of changed more recently to provide those things, but certainly if it's a firefighting lift in the last 3 months, then absolutely it should have all of the features that I mentioned earlier.
Perfect, thank you. Another one that's come through. Are there new codes or legislation to force owners to upgrade their lifts if they are modernising or replacing lifts in buildings above 18 metres?
So we've had some very good engagement with some clients and with the fire and rescue services on some of the projects that myself and my colleagues work with at the moment. What we find is that there's definitely a desire for people to work towards bringing lifts up to current standards. So it's not mandatory. There's no legislation right now. The lift equipment that you have would be dependent on when it was installed and would comply with the standards and laws applicable at that time. But as I say, there's certainly a movement towards improving the standards, and certainly I think my colleagues and peers in the industry would probably share the view that there's a desire for everyone to try and improve the standard. So if we can do it, we should try to do it. I think it's incumbent on us all to try and improve the standard of safety for everyone out there. We certainly believe this at TÜV Dunbarton.
Definitely. Thank you, Alan. Another question I have here, are the lift inspection checklist for a firefighting lift different from standard lift checklist?
So this, again, would be something you'd have to check with your maintenance provider. They certainly should provide arrangements for testing and inspection of the features. I did mention earlier that not all of those features are, it's not always possible for the lift maintenance company to test those things alone. The lift maintenance contractor can't test the fire alarm in the building. They can't test the backup power supply. So it should be a collaborative process where the lift maintenance company can make arrangements with the building owner or person responsible for managing the lift to arrange for those tests to be conducted. But certainly I would expect that your lift maintenance company should be able to provide you with the right advice on the inspection and testing regime for the lift. And once you've done that, you should certainly ensure that those arrangements are featured within the maintenance contract and within that regular routine inspection process.
I have another question here, which I'm not too sure on this one. We might be able to answer this here, but do we fit out interiors for firefighting lifts?
So when it comes to lift interiors, obviously what we need to think about here is combustible materials. So we don't fit out the interiors. The lift car and cabin needs to be designed for a firefighter's lift to ensure it meets with the standards. And again, that does address things like combustibility of materials and fabrics that are used. So typically you'd want a pretty plain lift car where you can't get many things that will go in fire. That doesn't mean they can't look attractive, but I suppose plain by plain, what I mean is in terms of design that accommodates all of the features required within the standard. There's many materials out there that can still provide what you need without combustibility. So there's lots of flexibility there.
Thank you for that, Alan. Another question here: which global standards are best for firefighters lifts?
Sorry, could you repeat that? The global standard?
Which global standards are best for firefighters lifts?
Well, I suppose, you know, we've got different international standards. There is no one global standard as such, you know, that other than international standards that apply. So in terms of best, I suppose there would be some debate as to whether or not a British standard is as good as American codes and, you know, other codes that feature in China, Middle East, etc. I think there's probably, you know, certain elements that could be taken from any of those standards, which would allow us to discuss what might be the best, but I think that's probably a matter of debate rather than a certain response or certain answer. There's different standards that are applicable in different areas.
Okie doke. I think that's all the questions we have at the moment. I don't know if there's any other questions come through. I think that's
hopefully we're not.
I found another one here. Sorry, I found another one. So it's getting mixed up in my my Q&A section here. Do you think pump should be provided by taking account of a presumed flow of water? Is it possible to presume flow of water anyway? Cables in well shall be resistant of fire. If yes, what's the requirement? Sorry, let me rephrase this because I don't think I've read it out too well. Do you think pumps should be provided by taking account of presumed flow of water? Is it possible to presume flow of water anyway? cables in well shall be resistant of fire? If yes, what's the requirement? Firefighter key in the car shall be the other than triangle key. Do you think it makes problem if the fireman cannot provide that key immediately during fire? It might be a little bit
So there's a few points I think in the
yeah,
question there.
sorry,
You
yeah.
know, with regards to sort of water and pumps, I mean the standards that in the past did talk about so many litres per minute. For example, of sort of water being delivered. Many of those things were around, I suppose, the sort of pressures that would be provided within the firefighters' hoses and on the sort of pumps and risers within the building. The lift, if you like, lifts that meet current standards, certainly in the UK, don't have to deal with pumping water from the shaft. The idea here is to prevent water getting into the shaft. If you do need to provide a pump, then obviously, I suppose you need to think about how much water you need to remove, but certainly that's sort of something that's been removed from the current standard. I think the emphasis now is on providing pumps that can be maintained from outside the lift, because there was often problems and risks associated with the maintenance personnel for the pump gaining access to a lift shaft. So I think we sought to resolve that. With regards to cables and fire resistance, the lift shaft itself is again, or when I talk about lift shaft, is within a firefighting shaft. So it's assumed that the lift shaft is within a fire protected area. So obviously if cables run within that shaft in a fire protected area, then they already have a degree of protection. If they run outside the shaft, then obviously maybe further protection within the cable, etc., might need to be considered. Again, that's for other building designers and M&E consultants to be engaged with, part of that discussion and process. The sort of final point, Paul, I don't know if I necessarily got that last part of the question there again. Could you just?
Yes, let me just see if I can get that for you. A firefighter key in the car shall be other than a triangle key. Do you think it makes problem if the fireman cannot provide that key immediately during fire?
So when people seek to do this, I think what's important is that the firefighters can get easy access to any of the switches and operate any switch that's associated with the lift. I think there's a sort of standard acceptance within the industry that the Delta, Euro, or sort of triangular key is one of the more common keys that are there. Firefighters do carry other keys, and you often find these. But I think what's important is that the local fire and rescue team don't find themselves in a situation where they cannot operate those switches. So again, probably up for discussion. I think standardisation is always good. It allows ease of use and ease of access to operate switches, etc.
Thank you, Alan. I think we'll wrap this up now. There's a few more questions come through, but we won't have time for those. So I think if you can ask those or answer those after, that would be great.
Yeah.
So thanks again for joining us.
Thank you.
It's evident to me that the firefighting lifts are essential safety edition to any tall building. As mentioned earlier, we'll be sending you a copy of the presentation and recording. Our next real estate webinar will be taking place in September, so keep an eye out for a registration email or visit our website to register your interest. Please get in touch, let us know if there are any other webinar subjects you'd like us to cover. It's great to know that what topics you're interested to hear about. Feel free to get in touch with myself or Alan for any queries you may have. On behalf of myself and our presenters, thank you for your time and enjoy the rest of your day. Thank you.